The planet Venus drifts through space, a quiet companion to Earth in the vastness of the solar system. It moves along its orbit in a slow and steady rhythm, circling the Sun at a distance that places it closer to our world than any other planet. Venus and Earth are sometimes called sister planets, not because they are identical, but because they share a similar size. If you were to place them side by side, you would see that Venus is only slightly smaller, its diameter just a bit less than Earth's. This similarity in size is a gentle reminder of how the planets formed long ago, condensing from the same cloud of dust and gas that swirled around the young Sun. When you look up at the sky in the early morning or just after sunset, Venus often appears as a bright point of light, glowing softly against the fading colors of twilight. It is one of the brightest objects in the sky, brighter than any star, though it produces no light of its own. The glow you see is sunlight reflecting off the thick clouds that wrap around the planet, clouds that never part or drift away. These clouds are made of tiny droplets of sulfuric acid, suspended in an atmosphere that is far thicker than Earth's. The atmosphere of Venus is so dense that if you were to stand on its surface, the pressure would be immense, many times greater than the pressure at the bottom of Earth's deepest oceans. Yet from a distance, Venus simply appears as a soft, steady light, a beacon in the morning or evening sky. The clouds that surround Venus form a smooth, unbroken layer, hiding the surface from view. These clouds are not like the fluffy white clouds of Earth. They are thick and opaque, pale yellow in color, and they extend high into the atmosphere. The wind moves them quickly around the planet, carrying them in a superrotation that circles Venus in just a few Earth days. Below these racing clouds, however, the surface of Venus is a place of stillness and quiet. The thick atmosphere presses down, and the air moves slowly near the ground, a gentle creep compared to the swift currents high above. Light from the sun filters through the clouds, creating a soft, diffuse glow on the surface of Venus. It is a golden, amber light, unlike the bright white light that reaches Earth. The entire sky on Venus would appear yellowish or orange, a warm hue that bathes everything in a gentle, muted illumination. There are no shadows on Venus, at least not sharp ones, because the light comes from all directions, scattered by the thick atmosphere. It is a world of soft edges and gradual transitions, where the landscape fades into the distance without clear horizons. Venus rotates very slowly as it moves through space. If you were to watch the planet from a point far above its north pole, you would see that it turns in the opposite direction from most other planets. While Earth spins from west to east, Venus spins from east to west, a slow backward roll that takes much longer to complete than you might expect. A single rotation of Venus, one full turn on its axis, takes about 243 Earth days. This is longer than the time it takes for Venus to complete one orbit around the Sun, which is about 225 Earth days. So in a curious way, a day on Venus, measured from sunrise to sunrise, is actually longer than a year on Venus. Imagine a world where the sun rises very slowly in the west, drifts across the sky over the course of many weeks, and then sets slowly in the east. The passage of day and night on Venus is so gradual that you would barely notice the change from moment to moment. The sky would brighten almost imperceptibly, remain lit for a long stretch of time, and then dim again just as slowly. There would be no sudden transitions, no quick dawns or dramatic sunsets, only a slow, gentle shift from one state to another. The surface of Venus is warm, much warmer than you would expect for a planet only slightly closer to the Sun than Earth. The thick atmosphere traps heat, holding it close to the surface in a process that keeps the temperature high and constant. Day and night, the temperature remains nearly the same, a steady warmth that never cools. The heat comes from the Sun, but it is the atmosphere that holds on to it, preventing it from escaping back into space. This is why Venus is the hottest planet in the solar system, even though Mercury is closer to the Sun. The clouds and the dense carbon dioxide atmosphere create a gentle, persistent warming that never lets up. The landscape of Venus is varied, with mountains, plains, and volcanic features spread across its surface. There are highlands that rise above the surrounding terrain, their slopes gentle and worn smooth by the slow processes that shape the planet. Some of these highlands are large, spanning thousands of miles, while others are smaller and more isolated. The plains of Venus are vast and flat, covered in solidified lava that flowed across the surface long ago. These plains stretch for great distances, unbroken by water or vegetation, a quiet expanse of rock and dust. Volcanoes are common on Venus, scattered across the surface in numbers that far exceed the count on Earth. Some of these volcanoes are tall and broad, their slopes rising gently toward a summit that may or may not have a crater at the top. Others are smaller, dome-shaped features that formed when thick lava oozed up from below and cooled in place. The volcanoes on Venus are not currently erupting, at least not in any way that has been observed, but the surface shows signs that volcanic activity occurred in the past, reshaping the landscape in slow, steady flows of molten rock. There are no oceans on Venus, no lakes or rivers, no water anywhere on the surface. The heat and the atmosphere have long since driven away any water that might have existed in the planet's early history. What remains is a dry, rocky world, shaped by heat and pressure rather than by the flow of water. The surface is a place of stillness, where nothing moves quickly and nothing changes in any dramatic way. It is a world frozen in a kind of slow time, where the processes that shape it unfold over millions of years. When you look at Venus from Earth, you can see that it goes through phases, just like the Moon. Sometimes Venus appears as a full disk, bright and round, when it is on the far side of the Sun from Earth. At other times, it appears as a crescent, when it passes between Earth and the Sun. These phases change slowly as Venus moves along its orbit, and they were one of the first pieces of evidence that planets orbit the Sun rather than the Earth. Early observers noticed these phases and realized that Venus must be circling the Sun, sometimes showing its full face to us and sometimes showing only a sliver. Long ago, before telescopes, people could still see Venus in the sky. It was so bright that it caught their attention, and they gave it names and wove stories around it. Different cultures saw Venus as a symbol of beauty or as a herald of the morning or evening. It was called the morning star when it appeared before sunrise and the evening star when it appeared after sunset, though it is not a star at all. The ancient observers did not know that it was the same object appearing at different times, but they watched it carefully, noting its movements and its brightness. When the first telescopes were turned toward Venus, observers saw a bright, featureless disk, glowing softly in the eyepiece. The thick clouds prevented them from seeing any details on the surface, and for a long time, Venus remained a mystery. People imagined what might lie beneath the clouds, some guessing at oceans and jungles, others picturing a world similar to Earth. It was not until spacecraft visited Venus that the truth became clear. The surface was hot and dry, the atmosphere thick and heavy, and the conditions were far harsher than anyone had imagined. The first spacecraft to reach Venus were simple probes, designed to pass by the planet and take measurements from a distance. Later missions sent probes into the atmosphere, and some even landed on the surface. These landers did not survive long, just an hour or two, before the heat and pressure overwhelmed them. But in that short time, they sent back information about the surface, taking pictures and measuring the temperature and the composition of the atmosphere. The images they returned showed a rocky landscape, lit by that soft golden light, with a sky that was thick and hazy. The Soviet Venera missions were among the first to successfully land on Venus and send back images from the surface. The landers showed a world of flat rocks and dusty soil, a place that looked desolate but strangely calm. The light was dim but steady, and the horizon was close, hidden by the thick atmosphere. Later missions mapped the surface using radar, peering through the clouds to reveal the mountains, valleys, and volcanic features that shaped the planet. These maps showed a world that was complex and varied, with geological features that hinted at a long and active history. Venus has no moons, no small companions circling it as it moves through space. It drifts alone, a solitary planet in its orbit. This lack of moons is one of the things that makes Venus different from many other planets in the solar system. Earth has its moon, Mars has 2 small moons, and the giant planets have dozens. But Venus has none, and the reason for this is not entirely clear. Perhaps any moons that might have formed were drawn into the planet long ago, or perhaps Venus never had the conditions necessary to capture a moon in the first place. The orbit of Venus is nearly circular, more so than most other planets. It moves around the Sun in a smooth, regular path, maintaining a nearly constant distance from the Sun throughout its journey. This circular orbit contributes to the steady conditions on the planet, with little variation in the amount of sunlight it receives over the course of its year. The orbit is tilted only slightly relative to Earth's orbit, so Venus and Earth pass relatively close to each other on a regular basis, closer than Earth comes to any other planet. The thick atmosphere of Venus is made mostly of carbon dioxide, with clouds of sulfuric acid floating high above the surface. This combination creates an environment that is very different from Earth's. The carbon dioxide traps heat, creating the high temperatures, while the sulfuric acid clouds reflect sunlight, making Venus so bright in the sky. The atmosphere also creates a greenhouse effect, where heat from the sun is absorbed by the surface and then trapped by the atmosphere, unable to escape back into space. This effect is much stronger on Venus than on Earth, and it is the reason why the surface is so hot. The wind in the upper atmosphere of Venus moves very fast, circling the planet in just a few days. This superrotation is one of the mysteries of Venus, because the surface and the lower atmosphere rotate much more slowly. The mechanism that drives this fast wind is not fully understood, but it is thought to involve the way the atmosphere is heated by the sun and the way heat is transported from the day side to the night side of the planet. The result is a layer of fast-moving air high above the surface, while below, the air is nearly still. The surface pressure on Venus is about 90 times greater than the pressure at sea level on Earth. This is equivalent to the pressure you would experience if you were deep underwater, far below the surface of the ocean. The dense atmosphere presses down on the surface with tremendous force, and any object placed on Venus would have to withstand this crushing weight. The thick air also makes sound travel differently on Venus. Sound waves move through the dense atmosphere more easily than they do through Earth's air, so sounds would carry farther and would be lower in pitch, a deep, muffled quality that would make everything seem quieter and more distant. The temperature on the surface of Venus is about 900 degrees Fahrenheit, or around 475 degrees Celsius. This is hot enough to melt lead, and it is nearly constant across the entire planet, day and night, equator and poles. The thick atmosphere distributes heat so effectively that there is very little temperature variation anywhere on the surface. The heat is not the result of being close to the sun, but rather the result of the greenhouse effect created by the dense carbon dioxide atmosphere. The sun's energy is absorbed by the surface and then trapped, creating a steady, pervasive warmth that never diminishes. The golden light on Venus creates a kind of perpetual twilight, a soft glow that illuminates the landscape without creating harsh contrasts. The light filters through the thick clouds, scattering in all directions, so that the sky appears uniformly bright. There are no blue skies on Venus, no clear views of the sun or stars. The sky is a dome of soft yellow-orange light, unchanging and calm. This diffuse lighting makes it difficult to judge distances on Venus, because there are no sharp shadows or clear landmarks to provide reference points. Everything blends together in the hazy atmosphere, creating a sense of quiet isolation. The rotation of Venus is so slow that the sun would appear to move across the sky at a pace that is almost imperceptible. If you could stand on the surface and watch the sunrise, you would see the sun slowly creep above the horizon over the course of many days. It would take weeks for the sun to reach its highest point in the sky, and then weeks more for it to descend again toward the opposite horizon. The entire process, from one sunrise to the next, would take 117 Earth days, a long, slow cycle that would feel more like a gradual dimming and brightening than a true day and night. The mountains on Venus are not as tall as the tallest mountains on Earth, but they are still impressive features. One of the largest highland regions is called Ishtar Terra, and it contains a mountain called Maxwell Montes, which rises several miles above the surrounding plains. The slopes of this mountain are gentle, worn smooth by the slow processes that shape the surface. Other highland regions are scattered across Venus, each with its own unique features and characteristics. These highlands are thought to be the result of tectonic forces, where the crust of the planet buckled and folded, creating elevated terrain. The plains of Venus are covered in solidified lava, evidence of volcanic activity that occurred long ago. These lava plains are smooth and flat, stretching for hundreds or thousands of miles in some places. The lava flowed slowly across the surface, filling in low areas and creating a relatively uniform landscape. Some of these flows are relatively recent, geologically speaking, while others are much older, their surfaces modified by the slow processes of weathering and erosion that occur on Venus. Volcanic domes are another common feature on Venus, scattered across the surface like small hills. These domes formed when thick, viscous lava oozed up from below and cooled in place, creating rounded, dome-shaped structures. Some of these domes are isolated, while others are clustered together in groups. They are not very tall, usually just a few hundred feet or so, but they are numerous, and they contribute to the varied landscape of the planet. There are also large circular features on Venus called coronae, which are thought to be the result of hot material rising from deep within the planet. This material pushes the surface upward, creating a raised ring with a depressed center. The coronae on Venus are hundreds of miles across, and they are often associated with volcanic activity. They are unique to Venus, not found on any other planet in the solar system, and they provide clues about the internal processes that shape the planet. The craters on Venus are relatively rare compared to the Moon or Mercury because the thick atmosphere protects the surface from small meteorites, which burn up before they can reach the ground. Only large meteorites make it through the atmosphere, and they create impact craters that are large and well preserved. These craters are scattered across the surface, their rims sharp and their interiors smooth. The floors of some craters are filled with lava that flowed in after the impact, creating flat, circular plains inside the crater walls. The surface of Venus is mostly rock, similar in composition to the volcanic rocks found on Earth. The rocks are basaltic, rich in iron and magnesium, and they formed from the cooling of molten lava. The soil on Venus is made of fine particles, broken down from the rocks by the slow processes of weathering. There is no erosion by water on Venus, because there is no water, but the rocks are still worn down over time by the effects of the heat and the atmosphere. Venus has a very weak magnetic field, much weaker than Earth's. This is thought to be because Venus rotates so slowly. On Earth, the magnetic field is generated by the motion of molten iron in the core, a process that requires the planet to rotate relatively quickly. Venus's slow rotation does not generate enough motion in the core to create a strong magnetic field, so the planet is largely unprotected from the solar wind, the stream of charged particles that flows out from the Sun. This lack of a magnetic field may have contributed to the loss of any water that Venus once had, as the solar wind could have stripped away hydrogen from the atmosphere over billions of years. The atmosphere of Venus extends high above the surface, gradually thinning as it reaches out into space. The upper atmosphere is cold and tenuous, a stark contrast to the hot, dense air near the surface. The boundary between the atmosphere and space is not sharp, but rather a gradual transition, with the density of the air decreasing slowly with altitude. High above the clouds, the atmosphere is exposed to the solar wind, and particles from the Sun interact with the gases there, creating a faint glow that can sometimes be seen from spacecraft. The clouds on Venus are layered, with different layers at different altitudes. The main cloud deck is about 30 miles above the surface, a thick layer of sulfuric acid droplets that reflects most of the sunlight back into space. Above this main deck are thinner layers of haze, and below it the atmosphere becomes clearer, though still thick and hazy. The clouds are in constant motion, carried by the fast winds of the upper atmosphere, but they never break apart or dissipate. They are a permanent feature of Venus, a veil that has hidden the surface for billions of years. The sulfuric acid in the clouds is created by chemical reactions in the atmosphere, where sulfur dioxide, released by volcanic activity, combines with water and oxygen. The droplets form high in the atmosphere and then slowly settle downward, but they never reach the surface. Before they can fall that far, they evaporate in the heat, releasing the sulfur dioxide back into the atmosphere to begin the cycle again. This continuous process maintains the cloud layer, a slow circulation of material that has been going on for eons. Venus is often visible in the sky just before sunrise or just after sunset, appearing as a bright point of light that seems to hang in the air. It is sometimes called a morning star when it appears before the sun rises, and the evening star when it appears after the sun sets. These two appearances are actually the same planet, seen at different points in its orbit. Venus is never visible in the middle of the night, because it is always relatively close to the sun in the sky, rising and setting within a few hours of the sun. This proximity to the sun makes Venus one of the first objects to appear in the evening sky and one of the last to disappear in the morning. The brightness of Venus is striking, often bright enough to cast faint shadows on Earth when the sky is dark. This brightness is due to the high reflectivity of the clouds, which bounce back about 75% of the sunlight that hits them. Only a small fraction of the sunlight is absorbed, and the rest is scattered back into space, making Venus one of the most reflective objects in the solar system. This high reflectivity, combined with Venus's relatively close distance to Earth, makes it appear so bright in the sky. The phases of Venus, as seen from Earth, change slowly over the course of several months. When Venus is on the far side of the Sun, it appears small and full, like a tiny disk of light. As it moves closer to Earth in its orbit, it appears larger but less than full, showing a gibbous phase, then a half phase, and finally a crescent. When Venus is at its closest approach to Earth, it appears as a large crescent, bright but with only a thin sliver illuminated. This cycle of phases repeats as Venus continues its orbit, a slow and predictable pattern that early astronomers noticed and studied. The discovery of Venus's phases by Galileo was one of the key pieces of evidence supporting the heliocentric model of the solar system, the idea that the planets orbit the Sun rather than the Earth. The fact that Venus showed phases, and that those phases correlated with its position relative to the Sun, could only be explained if Venus was orbiting the Sun. This observation helped to shift the understanding of the solar system, moving away from the old Earth-centered model and toward the modern understanding of planetary motion. The name Venus comes from the Roman goddess of love and beauty, a fitting name for the brightest and most beautiful object in the night sky. Different cultures have given Venus different names, but many of them also associated it with beauty, love, or fertility. The ancient Babylonians called it Ishtar, after their goddess of love and war. The ancient Greeks called it Aphrodite, their goddess of love. The Maya observed Venus carefully and associated it with warfare and sacrifice, noting its appearance and disappearance with great precision. The Maya were particularly skilled at tracking the movements of Venus, and they created calendars that predicted when Venus would appear and disappear in the sky. They associated these appearances with important events and used them to time rituals and ceremonies. The accuracy of their observations was remarkable, and their records of Venus's movements are still studied today as evidence of their astronomical knowledge. The exploration of Venus by spacecraft has provided most of what we know about the planet. The thick clouds prevented telescopic observations from revealing much, so it was not until spacecraft could visit Venus that scientists could learn about its surface, atmosphere, and conditions. The first successful missions were flybys, which passed close to Venus and took measurements from a distance. These missions revealed the thick atmosphere and the high temperatures, surprising scientists who had expected a more Earth-like world. Later missions sent probes into the atmosphere, and some of these probes were able to descend all the way to the surface. The descent through the atmosphere took about an hour, and the probes measured the temperature, pressure, and composition of the air as they fell. When they reached the surface, they took pictures and analyzed the soil, sending back data for as long as they could survive. The heat and pressure eventually destroyed the probes, but they lasted long enough to provide valuable information about the surface conditions. The Venera landers, sent by the Soviet Union, were the first to successfully land on Venus and send back images. The pictures showed a rocky landscape, with flat stones and a hazy sky. The light was dim, but there was enough illumination to see the surface clearly. The images revealed a world that was desolate but not entirely lifeless-looking, with rocks and soil that resembled volcanic landscapes on Earth. The horizon was close, just a few miles away, because the thick atmosphere limited visibility. Orbiting spacecraft have used radar to map the surface of Venus, creating detailed images of the mountains, valleys, and craters that cover the planet. Radar can penetrate the clouds, so it was possible to create maps of the entire surface, revealing features that had never been seen before. These maps showed that Venus has a complex geology, with evidence of volcanic activity, tectonic processes, and impact cratering. The surface is relatively young, geologically speaking, with most of it having been resurfaced by volcanic activity within the last billion years. The volcanoes on Venus have been studied carefully, and scientists have tried to determine whether any of them are currently active. There is some evidence that volcanic activity may still be occurring, with slight changes in the atmosphere that could be explained by the release of gases from eruptions. However, no active eruptions have been directly observed, and it is possible that the volcanic activity is very slow, with eruptions occurring only occasionally over long periods of time. The idea of life on Venus has been largely dismissed because of the harsh conditions on the surface, but there has been some speculation about the possibility of life in the clouds. The upper atmosphere of Venus, at an altitude of about 30 to 40 miles, has temperatures and pressures that are much more moderate, similar to conditions on Earth. Some scientists have suggested that microbial life could potentially survive in this region, floating in the clouds and feeding on chemical reactions in the atmosphere. This idea is speculative, and there is no direct evidence of life on Venus, but it remains an intriguing possibility. The study of Venus has helped scientists understand the processes that shape rocky planets, including Earth. By comparing Venus to Earth, scientists can learn about the effects of different atmospheric compositions, the role of water in shaping a planet's climate, and the long-term evolution of planetary surfaces. Venus and Earth started out very similar, but they ended up very different, and understanding why this happened can provide insights into the factors that make a planet habitable. The thick atmosphere of Venus is a reminder of how important the balance of gases is for maintaining a stable climate. On Earth, the greenhouse effect keeps the planet warm enough for liquid water to exist, but on Venus, the greenhouse effect has run away, creating temperatures that are far too high for life as we know it. This runaway greenhouse effect is thought to have been triggered by the loss of water from Venus, which allowed carbon dioxide to build up in the atmosphere without being absorbed by oceans or rocks. Once the process started, it was self-reinforcing, with higher temperatures leading to more water loss, which led to even higher temperatures. The loss of water from Venus is one of the key differences between Venus and Earth. On Earth, water plays a crucial role in regulating the climate and shaping the surface. Water absorbs carbon dioxide, forming carbonic acid that dissolves rocks and locks the carbon away in sediments. On Venus, this process could not occur because there was no liquid water, so the carbon dioxide remained in the atmosphere, creating the thick, heat-trapping layer that we see today. The question of why Venus lost its water is still being studied, but it is thought to be related to the planet's proximity to the Sun and its lack of a magnetic field. The heat from the Sun could have caused more water to evaporate into the atmosphere, where it was broken apart by ultraviolet light. The hydrogen escaped into space, while the oxygen either reacted with rocks on the surface or was stripped away by the solar wind. Over billions of years, this process removed most of the water from Venus, leaving it the dry, hot world that we see today. Venus rotates so slowly that the Coriolis effect, which influences the motion of air and water on Earth, is very weak. On Earth, the Coriolis effect causes winds to curve, creating the patterns of circulation that drive weather systems. On Venus, the slow rotation means that the Coriolis effect is almost negligible, and the winds move in more direct paths. This is one of the reasons why the superrotation of the upper atmosphere is so unusual, because it requires a different mechanism to drive the fast winds. The day-night cycle on Venus is so long that the temperature does not change much between day and night. The thick atmosphere holds onto heat so effectively that even the night side of the planet, which does not receive any sunlight, remains almost as hot as the day side. The slow rotation and the heat retention mean that there is very little temperature gradient across the surface, creating a nearly uniform environment all over the planet. The surface of Venus is hidden from view by the clouds, but the radar maps have revealed a world that is diverse and complex. There are vast plains, highland regions, volcanic mountains, and impact craters, all shaped by the processes that have been acting on the planet for billions of years. The surface is not static, but changes slowly over geological time, with volcanic activity occasionally resurfacing parts of the planet and erasing older features. The landscape of Venus is quiet and still, with no wind or weather to disturb the rocks and dust. The thick atmosphere presses down on the surface, creating a stable, unchanging environment. The rocks lie where they fell, undisturbed by water or ice, slowly weathering in the heat and the dense air. It is a world that is both alien and familiar, with features that resemble Earth but conditions that are completely different. The exploration of Venus continues, with new missions planned to study the planet in more detail. These missions will use advanced instruments to analyze the atmosphere, map the surface with greater precision, and search for signs of volcanic activity. Some missions will focus on the clouds, looking for clues about the chemistry and dynamics of the atmosphere. Others will attempt to land on the surface again, using new technologies that can withstand the heat and pressure for longer periods of time. The study of Venus is important for understanding the diversity of planets and the processes that shape them. Each planet in the solar system is unique, with its own history and its own set of conditions. By studying Venus, scientists can learn about the extremes of planetary environments and the factors that determine whether a planet becomes habitable or inhospitable. This knowledge can also be applied to the search for planets around other stars, helping to identify which exoplanets might have conditions suitable for life. Venus drifts through space, a bright and beautiful object in the sky, hiding a world of heat and pressure beneath its clouds. It is a reminder that the planets are not all the same, that each one has its own story to tell. The thick atmosphere, the slow rotation, the volcanic surface, all of these features make Venus unique, a planet that is both similar to Earth and completely different. As you drift off to sleep, you can imagine Venus in its orbit, glowing softly in the darkness, a distant world that continues to inspire curiosity and wonder. The light from Venus reaches Earth in just a few minutes, traveling through the emptiness of space at the speed of light. When you see Venus in the sky, you are seeing light that left the planet just moments ago, reflected off the clouds and sent on a journey across millions of miles. That light has traveled through space, crossing the void between the planets, to reach your eyes and create the image of a bright, steady point of light. The surface of Venus is a place where time moves slowly, where changes occur over millions of years and the landscape remains largely unchanged from one century to the next. The rocks sit quietly, the dust settles gently, and the thick atmosphere presses down with a constant, unchanging force. It is a world of stillness, a place where nothing moves quickly and everything is slow and patient. As the night deepens and your thoughts begin to drift, you can let the image of Venus fade into the background, a soft point of light in the evening sky, a reminder of the vast and quiet universe beyond. The planet continues its slow rotation, the clouds continue their swift journey around the atmosphere, and the surface remains hot and still. Venus is there, always there, a constant presence in the solar system, drifting through space in its own slow time. The golden light on the surface of Venus creates a world of soft shadows and gentle illumination, a place where the harshness of space is filtered through layers of cloud and atmosphere. It is a world that exists in a kind of perpetual twilight, neither fully bright nor fully dark, but somewhere in between, a quiet, calm place that invites rest and stillness. Let your mind settle, like dust settling on the plains of Venus, slowly and gently, until all is still and quiet. The thick atmosphere holds everything in place, and the heat wraps around the surface like a warm blanket. There is no rush on Venus, no urgency, only the slow passage of time and the quiet existence of a planet that has been here for billions of years and will be here for billions more. Rest now, as Venus rests, turning slowly in space, wrapped in clouds, glowing softly in the night. Let the warmth and the stillness wash over you, and drift into sleep, peaceful and calm, under the distant light of the evening star.